Well, hi, good morning. Thanks so much for joining me here in my shop. So, pretty excited about what I'm going to be doing today. I don't really know how it's going to work out, but the primary goal today is to find out why this radio doesn't receive the AM broadcast band. I have no idea at this point why this doesn't work. My belief is the radio component-wise is ready to go. But obviously, like all the components have been changed in it that need to be changed, and actually everything is working the way it should, except for, well, something. Except for something. So along the way to trying to figure out why the AM isn't working in this radio, I'm liable to stumble on a number of other interesting elements, which I'm going to dwell on because that's kind of the guy I am. You can't really see that. That's the schematic. The first thing I'm going to talk about, and I know you can't see this in the camera, but you don't really need to. So this is the loop antenna arrangement here. Actually, this right in here, that's this piece here. It's a permanently connected AM. I believe it's just an AM broadcast loop. There it is there. The interesting thing is just below it, there's a wire shown coming off, and it says capacity antenna lead. So the first thing I want to understand better is what is a capacity antenna. Now I've come across this a few times. Could be it's every time I have this type of chassis, along comes this capacitive antenna. So why don't we take a look at it first? What the antenna actually is. Now I have a notion about what this is doing, but it's only a notion, so I hope to correct that. Now let me put this here very carefully. There we go. So of course we're looking at the top of the radio chassis. So here is the capacitive antenna lead, and it simply runs up to this wire, which is zigzagging back and forth and comes to an end here. Looks like it's either been pulled out, it's been stripped back for somebody to connect more to it, which I'm not sure is a good idea. I don't know why it's out like that, but maybe somebody in the past has done that, thinking this is where you put an external antenna on this radio. Of course, there's a screw on the back of the chassis. That's where you hook up the external antenna. So this would normally be connected all the time. It's essentially connected to the antenna lead, the antenna screw, if you like. It's connected in a different manner, but it's pretty much the same thing. This is soldered in place, I'm pretty sure. Always connected. So what I believe this is an attempt to correct the impedance of a long wire antenna that is typically used with a big radio like this. So the people who built this radio had a reasonable expectation that when it got to the consumer's home, it would be tied to an antenna wire hanging out in the owner's backyard or something very similar to that. Some kind of wire, maybe inside the house, but still a length of wire. And I think everybody back in the day knew longer and higher meant better. So the makers of this radio could anticipate it being connected to a piece of wire 50 feet long anyway, something like that. So my thinking, this is just my thinking here, is that that length of wire produces at most frequencies a inductive load. So that makes a mismatch with the antenna. Power transfers lessened, so the antenna doesn't work as well. It appears to not work as well. So one way to compensate for that would be to put a longer and longer wire out, or another way is to add some capacitance. Now there's a bit of a problem with what I just said, and I won't go into it because I don't fully understand it, and I don't expect myself to fully understand it at this point. But there it is. In other radios, this capacitive antenna has been a sheet of aluminum foil, basically this size, with a wire coming down from it. Now this one, it's a piece of wire. That's a cheaper construction. And I noticed they wanted the wire to go back and forth. They probably wanted it to be spaced equally here, but they couldn't because of this. So they brought it and they just decided to do it the way they've done it. Is this a very particular length of wire here? I don't know. I don't know. It looks to me like it's 3 times across and that's it. So, so exactly what the capacitive antenna is, I don't know exactly. An interesting thing I learned I'm going to make a little diagram here and just, I'm going to share something I learned this morning because I think it's very interesting. And come on there. I'm just going to make some sketches on the back here. So think back to when you were a young person and in the 1920s, and ships were sailing the ocean. Here's a ship. And if you looked at the antenna on top of the ship, they'd have a mast here and a mast here. And then they'd have a cross arm and a cross arm. And then there'd be a series of wires going across. Not one wire, but a whack of wires. And here's the ship radio guy sitting here. And there'd be leads. I think they connect these together like this, and they bring a lead down, or they bring a bunch of leads down into the radio area where the radio is on the ship. Look, I forgot the water, right? I gotta have some water here. There we are. So, what's going on here? What is all this? Well, this part's been described as a capacitive element on the antenna. The idea being, way back in the day, you were working with extremely long wavelengths on a ship that's not nearly big enough to handle a long piece of wire. So the arrangement was made this way. The interesting thing is, if you did away with all this and just use this as your antenna, then I'll draw it over here. Here's the transmitter. If you drew a graph of current flow in this antenna, you would see it something like this. So most of the current, heady current, is here, of course, close to the transmitter. For a receiving antenna, it's just all turned around the other way. And by the time you get to the top of this antenna, there's not much current left. In fact, right at the top, there can't be any current, can there? Right at the very top. There can't be any current. So the result is, the bulk of the current, which is the bulk of what's going to put out your signal, is located low. You'd rather have it up here, not down here. In fact, this part is not doing much of anything. So how do you get the current up here? You extend the antenna. You extend the antenna using these wires. The result of this is more current. This graph, if you like, changes. It looks more like this now because of the current flowing up here. And the result is you get more current flowing in the higher part of your antenna. Now that's what's going on with these wires. I've always wondered, why did they, early days, why did they make wires like these kinds of antennas, and why don't we anymore? I'm sure cheaper ways were determined in the end, but in the early stages, this was very common. You see lots of pictures of this thing going on. This is what's in my radio, I believe. That's what it is. It just doesn't quite look like that. You have the radio here, you have a little capacitive antenna thing there, and then you have a long wire coming out. I think that's what's going on. Is this throwing off the broadcast band reception in this radio? No, it cannot, because when this radio is receiving broadcast band, it's using the loop antenna in the back. There we go. I kind of thought that through. Settled that one right here. Okay, so question now is, so the end of that discussion is, you really shouldn't be too concerned about that capacitive antenna connection just yet. Later down the road, especially during the final stages of alignment, then it might become important to make sure that that capacitive antenna is connected. That's probably the case. That's probably all I need to know about it. So what I'm going to do is I'm going to run this radio. We're going to first just try to pick up some AM radio again, just using the antenna. Then I'm going to feed in some test signals, try to pick those up, try to get something coming through the broadcast band on this radio. Once we get something coming through, then I can have a little more fun with my signal tracer, try to trace where the signal gets to before it weakens, disappears, or whatever. That's kind of the general approach I want to take. That's why I've got my signal generator running over there, and my signal tracer. Well, the first thing we're going to do anyway is we're just going to hook this up to the antenna and give it another go, just to be sure. That thing. Okay. Put this on. So I've hooked up my outdoor antenna. I'm sure is not switched in here now. So I'm going to switch on the radio, I'm going to let it warm up, I'm going to run, throw the antenna switch down yonder. How about we plug it in? That's always helpful. Always helpful. Okay. Just watching the dim lights there. There we go. Perfect. So I'm just going to leave it on like this. I'm going to run and throw a switch and be right back. Okie dokie. Just put it on full power here. Turn it up. Sounds like the AM band right now. Oh. Okay, what's happening? Loose ground connection. Okay, that's what's happening there. We're not on the broadcast band. Broadcast band. Man alive. You know, I spent an hour yesterday running around my house trying to figure out where this sound comes from. I did not. So, this is not this radio. This is an interference sound that is on my antenna. And I could not for the life of me figure out what it was. So let's just keep going. Just pretend that knocking sound isn't there. You know what? That's all there is on AM, on this radio. Okay, enough for the antenna. Look at that, even without the antenna connected, it's still picking up that sound. What is it? So this radio is currently tuned plates closed. Which end is that? I can never remember. Plates open, plates closed. Listen to the ticking. It slowed down? What is it? What the heck is it? That's the strangest thing. It's not just that it's noise. It's that this ticking changes pace. Mysteries. So I'm going to blast in a signal in the back of the radio antenna from the signal generator, see if we can pick it up here. Blasting is right. Somebody tell me what the heck that is. What could that possibly be? You know, an oscillation in a radio that causes that motorboating sound. This sounds exactly like that. The change of pace, you know, the popping, clicking, unusual sort of sound. The here today, gone tomorrow, back the next day, the randomness of it. It all suggests something going on in a radio circuit, to me, or electronic device of some sort. But for the life of me, I've almost pulled the power to my entire house to make this thing come and go. I have not found a single thing in my house that I can interrupt that affects that sound. The frustrations of it all. Now, I've got the radio tuned probably out of the range of the signal generator, so rather than move the signal generator, I'm just going to tune the radio volume up. Now the ticking is gone, we can turn the volume way up. Where did I hear that before? Like, what makes a noise like that? Now, this will be on all the radios in my house, depending upon the location in my house. Because this signal is up and down, different places you can't hear it, other places you can, but it just seems to be at random. No, don't get too sidetracked here, Jim. I don't think it's this radio at all. So no sign of the signal generator here. I'm now pounding in a strong signal that any radio would receive. Well, it's quite clear. Absolutely nothing is getting through this radio. That's kind of surprising. So let's try the IF frequency through the antenna. I'll change the signal generator. Well, we know the IF works. There's no reason for me to do that. Signal tracer time. Let's go at it with a signal tracer and see if we can trace the signal generator signal into the radio at distance. A little further over here. See the magic eye coming on here. Well, it's hard to see in the camera, isn't it? Magic eye has never proved very useful to me. Okay, I'm gonna put the signal tracer ground on the chassis. Signal tracer up. Now, on the video, it can be confusing as to whether you're hearing this radio that I'm working on or the signal tracer, so I'll try to help you. Signal tracer is tuned to receive AM radio like any AM radio would. Not quite any radio, but... So I'm going to go right on the antenna terminal on the back of the radio here, basically the output of the signal generator, and we're going to find that first. So make sure the signal's on the antenna here. Okay. There it is, 960 according to this dial. And you can see the signal generator is 968 on there. So that's the signal that's getting to the back of the antenna. Oh, my cat is showing up here. Okay. Now, let's see. The next major stopping point for the signal that's worth looking at is grid of the first tube here. First tube is an RF tube, and the grid is pin 1, 2, 3, pin 4. Pin 4 off this capacitor. Pin 4 of that tube, and to be sure, that tube is located right down in here. Let's get at pin 4, huh? Can I make it? Barely. So pin 4, 1, 2, 3, and 4. 4 has a correct capacitor connected to it. So this is what is on the grid of the first tube. Let me just turn this down a little bit before we... So do you hear it? It's just barely there. Okay, so what have we done now? What have we done here? Again, I know you can't see this clearly on the camera, but again, that's okay. For this point, we need to look more distinctly at the schematic, I'll put it on my computer screen. So here's the tube I just checked. There's the grid. The grid goes back. Now this way it meets up with a big resistor, 2.2 megohms, and then on to the AVC source. So 2.2 megohms, no, the signal's not coming that way, it's coming this way, through this capacitor, through switch 1, and then we have some, this is the big tuning capacitor, the big air-plated capacitor, if I can say that. A bunch of coils and just a bunch of front-end stuff here. You have two wafer. This is switch 1, the front of the wafer. This is the back of the wafer. So it's all happening with the number 1 wafer on the switch. And it's basically switching in different sets of coils as you snap through the different bands. So it's selecting one set of coils here. We should be able to figure out which set it is and exactly how the signal is going through here. Can you possibly see this on camera? Well, yeah, it's a real hassle for me to flip back and forth between the computer screen and the camera here if I'm going to do it again and again and again, so I don't want to. So absolutely no signal coming out. What are the chances that there's no local oscillator running? And that's really the problem. And when we get down to the AM band, the local oscillator stops oscillating. Maybe we should verify that, because that's fairly easy to verify before we go any further. I can't say I've ever encountered a radio that's not working in that respect. But let's double check and be sure. Give me just a moment here, I'll get that all set up. Okay, so on the screen now you're looking at the spectrum display of my SDR radio. Just an interesting side note. You know, I love all these side notes and distractions. If you look on my SDR and you see this peak, and this one, and this one, and this one, and you probably hear my cat meowing, and this one, and this one. The frequency of this first one, because this is 0 hertz here, 96 kilohertz exactly. What a suspicious number that is. 96 kilohertz is double 48 kilohertz. 48 kilohertz is the switching speed in my sound card, in most sound cards. So is that what this is? Here it is here, double, triple, quadruple, all the way up, way up into the very high ranges. So is that what I'm seeing here on my SDR? Is interference sort of coming from the switching of my sound card? Don't know. Thought that was interesting though. But what we really want to look for now is a local oscillator here. Oh my gosh, Peanut, really? Peanut's my cat, by the way. So what I'm going to do now is I'm going to move the antenna of the SDR around the back of the operating radio and see if some signal shows up. The radio is tuned, I don't know, somewhere in the middle. I think this is the oscillator down here. So we're looking for something new on the screen as I move the antenna in and out. That's my hand on the antenna checking it. Make sure it's working. How about up here? Anything. So to see something new on here, I'm looking at the waterfall display. That's the easiest place to see if something new shows up. I should probably have just studied. I think this is the oscillator here. Well, I don't see anything. No, wait a minute. This is exactly what I'm suspicious of, that there is no oscillator oscillating down here. Okay, so let's go to shortwave band, next band up, because I know at least I believe it's receiving. So I'm going to switch the radio here. And I turn the volume up so you can hear what's going on. Very mysterious thing there. We're going up one band. Oh yeah. So now there's a ton of signal coming through the radio. Now this band is what was it? What is the band range here? Uh-oh. Is that easily available? It's somewhere around 2.5 megahertz up to... Let me look at the radio. 2.5 megahertz up to 7. So I'm going to switch my signal. Okay, hold on, I got a lot of things to change. Let's start with this. You're looking at this on the screen. So I'm going to move this up into the range that we're receiving now, up around here. Could be all the way up to 7. So somewhere in here. Let's put it in the middle. So the middle of 2 and 7 is 4. So here's 4 megahertz right here. First, I'm just going to tune the radio a touch here. Wow. Okay. Wow. Do you see anything moving on the screen there? You sure do. Okay, let's see which one of these is the real McCoy. So I think it's the one I put right around 4 here. I think the one that's at 4 megahertz now, where the red line is the local oscillator. Now to prove this, let me turn down the radio. I have to know where the radio's tuned, at least roughly. Let me look at the plates. Here, and take a look. We're about halfway through the tuning range, so we're around 4. Does it make sense? 4 megahertz. The IF in here is all of 455, 4 megahertz, 3.5. So the radio should be tuned to around 3.5. If the local oscillator is at 4, the radio is trying to tune somewhere down around here, 3.5. So I'm going to put a signal into the radio at 3.5. See if it comes out of the speaker. That's the idea here. We can, yeah, you can watch it on this. I think. I don't know if it'll show up or not. Let's see. 3.5. 3.5. Okay. 9, 8, 7 megahertz, 6 megahertz, 5 megahertz, 4 megahertz. Wait a minute. Coming in on 4. Okay, we're at 4 megahertz signal now. And I've got the microphone right in front of me here. Oh, you can see it. Right around the 4. Just above the 4, you see something moving to the right, and now moving back to the left. That's the input signal from my signal generator. We're heading down around, well, 455, less than 4 million. So somewhere around 355, something, any time now. There it goes. So very interesting. Now watch how that signal gets bigger as it starts coming in. Actually, it got a little smaller, didn't it? Well, it's a curious effect, but that's okay. So let's tune the radio maximum here. Right around there. So on the SDR, I read that as 3550. That's exactly what it should be. If the IF is 455 and the local oscillator is at 4. Okay, so we see the local oscillator. Let us now go back to the AM band. Repeat this kind of test. Okay, we're on the AM band. Are we? Really? Just be sure. And no, we are not. Well, I stopped short. What's going on there? Okay, maybe did I have just the band settings mixed up? No, I couldn't have. There's our familiar funny sound from AM. Move the SDR back down to the AM range. Here's the AM radio band right in here. Now we want to find the local oscillator. So if the radio is tuned in the middle, then it's tuned for around a megahertz, and the local oscillator should be at around 1455. So we look on the radio here, 1455. Okay, so I'm going to tune the radio just back and forth to make the local oscillator wiggle. Anybody see anything happening there? I'm just going to move the pickup coil a little bit. I think there's no local oscillator for the AM radio. I think that's what I've determined here. tuning the radio doesn't make any difference. Okay, let me show you what I'm doing here exactly. In case this has all been a mystery to you, so what I'm doing while you're looking at the screen. So this is the antenna going to my SDR radio. This is now the antenna input to my SDR radio, which is hidden in behind here. You can't see it. But, so this just comes around, just a loop of wire. I could do this in any one of a number of ways. Okay, there's nothing to this. Now look at the different coils in here. You know, from experience, I can kind of recognize this is probably the oscillator coil here. You know, just looking at it. These are all antenna coils that are being switched through. You know, this might be an oscillator coil up here. I'm not exactly sure. So I put this near each one of these, and then I look on the SDR, which we can't see at the moment. What I found was when the antenna is down in this area, the local oscillator was easily seen on shortwave. And then we switch to the AM radio. I keep the antenna pickup here for the SDR. Nothing, nothing, nothing. Look around, nothing, nothing, nothing. So I think that's really quite conclusive. Now the question is, why would a local oscillator operate on the shortwave bands but not on the broadcast band? The answer has to be clearly a problem with components that are only engaged during broadcast band listening. And that would be potentially a broadcast antenna coil, some kind of coil, open coil, something like that. Defective capacitor, not letting a signal through. I'm pretty suspicious about that. And shorted capacitor, draining everything out, that's quite possible too. Open resistor, that's possible. Failure in the antenna, no. Problem is a local oscillator. Can't be too many components in the local oscillator that can do these following things. Those previous things. Yeah, I'm the one who's doing the following things. So what I'm going to do, I'm going to stop for a while. I'm going to examine the schematic. When I come back, we'll probably study this part of the schematic very carefully and try to identify any capacitors that are in trouble in there. In the meantime, I'll be a nice friend to my cat. Is that right, Peanut? Right. Okay, see you in 10-15 minutes, which is a few seconds, video time. Okay, so you can still hear the radio making that strange sound. I'm just going to turn it down. You know, I've heard another radio make exactly that same sound. So again, that's interference in my house. And exactly how that's coming through the radio if the local oscillator is not oscillating, I don't even know. So it's all interesting stuff. But let's take a look at the schematic here. Now, I think just before I went away, I was saying this part is the oscillator circuitry. No. There's three sets of tuning here. There's a set here, and there's a set here. This one down here is the oscillator tuning. So this is where the action probably is, or the lack of action probably is down here. So now, just in terms of the parts I replaced, the two capacitors I re-replaced. One is this one, and the other one is this one. And so my question would be, is that what's causing all this trouble? I can't see how, because this isn't in the local oscillator circuitry. In fact, if you look at the mixer tube, you can see two wires coming down here and heading over to this whole circuit block here. Great. So here we are. So these are the oscillator coils, and this switch, S3, front, rear, S4. Oh my gosh, there's a fourth. I thought there were three wafer switches. There's actually a fourth one. The 3 and 4 are very close together in the radio. So anyway, these switches are operating to select one of these coils each time. So let's see, here's the A band coil, a trimmer. There's a capacitor that the whole signal has to pass through this, or maybe not. What's this up here? So at this point, my brain gets really soggy when I start seeing these various connections into these switches and that. Quite soggy, in fact. This almost looks like it's applying a ground. like it's snapping a ground in place. This is the ground, and this is selecting which of these wires gets the ground. But I don't know for sure. I'd really have to study this. In fact, you know, I think in studying it, I think this is the, I can't see. This is just not, well. So this is the main one here. This lead wire is the one that is always in contact with the slider. And the switch in the position it's in right now is hooking up this wire. I think this circuit diagram is shown with the A band operating. Now that would be a pretty good assumption. I'm reading all these notes very quickly here. I haven't seen anywhere where it says the circuit diagram is showing A band connected. Well, can we figure that out from here? Can we possibly? Oh my gosh. Can we figure it out from here? So here's B. Here B. Hey, where's A? What's going on here? They've got a primary here and a primary here. Okay, so it's all, you know, the closer you look, the more complicated things seem to get all the time. This is not helping me at all. So I can't really tell if the radio is being shown with A band connected. I can't tell. Broadcast band, I shouldn't say A band. Son of a gun. Okay, so what can we do here? If it isn't oscillating, there's not a lot to like trace down to, you know, you can't find out where the signal stops because it never starts in the first place. I think I would so what's going through my head now is if you switch this onto another band other than the broadcast band, is this just deadened out? This is just no longer of any consequence. Probably the case. And so I'm wondering, okay, so how can you have a component failure in here that only affects the A band? Because this part of the, this is complicated. See the switch has a large wide area here. This one too. So, you know, it's switching in collections of these coils. It's not going 1, 1, 1. It's going 1, 1 plus this one, 1 plus this one, this one. And you can see it up here quite clearly, how it's being done here. Well, that's actually not so clear either, is it? Oh my gosh. I think this is the tap out that the feedback is created from. Assuming we go out here. Oh my gosh, I don't know. Yeah, my head's going to come apart if I keep studying this, so I don't have to understand it fully to perhaps find out what's going wrong. So this is definitely an implicated capacitor here, and this one too, I would guess. Either one of these could be in trouble. Now, how do I go about? How do I go about? Well, I can just start by working in circuit, find these two capacitors, test them, find out maybe one of them shorted out. Maybe I can find out really quick. Or maybe there's something about them. Maybe I changed these out and did it wrong or something. I don't know. I don't know for sure. I just don't know. Now, what else could be blocking only this? I think it's only these. Or, you know, open coil. You know what? Testing this coil is fairly easy. L17. L17. Is there a mini diagram of L17? L17. So let's see if we can find L17. I don't think we're going to find it. Well, we might. Oh, see, now instead of saying, well, what's this? I'm using L numbers like this now. L2. Here we go. L2. That's an R. Oh my God, I'm going to go nuts
gosh, looking at this. Here we are, L12. I forgot which one I'm looking for crying out loud. L17. L13, 14, L17. Here it is. Oh my gosh, look at all the stuff on there. C36. So these must be oscillator adjustments here, these trimmer capacitors. Oh boy, it's hard to look at this. It's just as hard as looking at the regular radio. So now, it's somewhere in this tap L17, L16, L13, L14, L16, L17. There must be two coils on this form. Okay, so there's two coils on this form. One of them is the L17. It would look like it would be between this lug and this lug. That's where the coil would be. And then the 16 lugs, no, tap L17. Well, I'm just going to read a bunch of resistances around here, get some information, and then continue scratching my head because of what? The chances of this being open is really, really low. It's far more likely something's happened here. So this is L17, C39, A and B oscillator. Well, there you are right there. A and B oscillator coil. Oh boy. Another thing I could do is I could just parallel some of these capacitors and see if the oscillator shows up. That I can do with the radio operating. C36, C39. How big are those guys and where are they? Well, there's C39. There's C36. C39 is showing up a few times here and it's a big one. Okay, let's do this. Let's make an assumption. This is the problem right here. Now, if this is the problem and it's shorted, I can find that out with an ohm meter. If it's got no capacitance, there's a couple things I can do to find that out. And lastly, I could parallel it with a 5600 picofarad capacitor. See what happens. Let's find this guy. Find this guy. 39. Okay, so it's not that hard to find because it's on this diagram. So I just got to figure out where. So it's right up near these capacitors here. C39. Okay, let's go back to the radio.
Oh, it's a lot different when you start looking at the radio again. So here's the three capacitors down here. This must be the coil right here. You can see capacitors I've connected. Oh. You know what I've done? I'll bet you what I've done. I did the same thing here that I did over here, and I installed what I had. Not necessarily what needs to be there. There's another one down here to ground. So I think I'm going to review these three capacitors I've put in and figure out from there whether I've done the right thing or not. Okay, so that's going to be a lot of head fiddling, so I'm just going to do it off camera here. Well, okay, so after analyzing the schematic here and the circuit, the coils, and all that stuff, and believe me, this really is, I find this really challenging, and I don't find it too surprising that it looks like I've made a big boo-boo. This capacitor is terribly wrong sized, and this one down here, this capacitor that goes to the chassis, you can't really see it in there. Here, let me switch to the close-up camera. Okay, so let's just go back now. So I put this one in, that's the correct size. Put this one in, this is way, way, way off. And then this one back here, this one, which is going to the chassis, I can't find that on the schematic anyway. I have no idea what was going on in my head here. So I'm going to guess that when I was fixing up this radio, I misinterpreted the schematic. I got confused among all these coils. You know, there's a lot of coils in here. And when you look at the like for instance, as an example, sorry it's a little out of focus, but you see that coil, and that coil. Those three coil forms on the schematic look more like this. So at a glance, they all look like they're one coil form. You know, same sort of thing down here. These are the actual ones that we were just looking at. It looks like one coil form, but it's not. It's broken out into three forms. So there's lots of ways to get confused. And I find most of them usually when I'm working on it. So what I'm going to do, I'm going to double check. I'm going to take a little break here. I'm going to double check everything I did. Remove this. This is probably the one that's killing it. This is grounding out the signal. This is stupid why this is here. And this one I'm going to switch to the correct size. This is all in a tuned area, so you got to get these close, if not right on. They got to be pretty darn close. I guess within the range of the trimmers.
So I'm going to go ahead and do those things after a little break, and then we'll try the radio again.
Okay, so I managed to replace this very incorrect capacitor. This is like 100 times bigger than it should be. It's way out. With proper size, I had to parallel two capacitors to get there, but proper size capacitor. What I haven't done is I haven't done anything about this mysterious, can't quite see it there, this mysterious capacitor I installed down here last time, grounding this terminal to the chassis. You know, nothing like that appears anywhere on the schematic. I'm sure it's an error. The part that's got me really hesitant is if you look in the camera very carefully, you can see that there's a lead sticking out which I cut off, and then I soldered this to that lead. What was here? What was here? I mean, you would guess, well, it must have been a capacitor from here to the chassis, and I simply replaced it. But nowhere does such a thing appear on the schematic. So what's got me really hesitant now is that perhaps this capacitor to ground is supposed to be there. It's just supposed to be somewhere else in the radio, maybe at the other end of this black wire or something. And I made it convenient for me by putting it here. I don't think that's the case, but I don't know. So what I'm going to do is turn on the radio the way it is, new capacitor here, see if it works. If it works, okay. If it doesn't, I will nip this, and we'll see if the radio doesn't come right back to life at that point. That's the plan of action. So that's, now I've done a little bit of capacitor work, so let's just keep an eye on that. Lights are good, all is good, everything's good. The sun is shining outside, that's fantastic. I haven't seen sunshine for a few days now. Okay, put this on full power. Now, are we on the AM band here? Just rotate this very carefully. Let's see. Yes, we're switched on to band A. Volume. Sound a little different? Okay, let's tune it. No, there's no difference here. Okay, plan B. Cut this guy. Let's leave the volume up just a wee bit. There we go. How do you like that? That sounds a little better. Well, from now on I can never ever be critical of anyone else's work in a radio that ends up on my bench, because here's my own work ending up on my bench with a stupid mistake in it. Great. Well, anyway, we solved that. That's fantastic. Now we can probably get on to the alignment of this radio. Yeah, I think that's it. Hey, let's put an antenna on it. Come on, don't miss the fun part, Jim. Come on. Okay. Antenna. Doesn't sound any different. If they heard that strange sound just now, that was my stomach actually. Getting louder as we go. Okay, so that's fully open. Fantastic. That's it. Great. Okay, that's fantastic. I actually did what I set out to do today. That's amazing. Thanks so much for watching, and next thing is alignment of this radio and the peaking up of its performance on all its bands. See you in the next video.